Well, here we are at chapter 6. We're going to be using the normal distribution to calculate probabilities. So here is a normal distribution, or a bell-shaped curve. We have the mean in the middle. In this particular section, we're going to just deal with a simple case where mean equals 0, standard deviation equals 1. And if this was a calculus-based stat class, then we would use integration to calculate area or probability. Since we are not calculus based, then we're going to use table A2 to look up these probabilities or areas. One thing you need to notice is what area is being found. So in this particular table, it's from whatever z-square is given to the left. The other thing to notice on this table is the way you use it is you look, let's say that z is equal to 2.51. So on this side you would look for 2.5. So here's 2.5. And then for the last decimal place, if it was 2.51, then you would look right here. And you see where that column and that row meet. And it meets at 0.9940. That means that this shaded area over here, boy, that's not very pretty, is 0.9940, or 99.4% of the data. So for example number 1, find the probability that z is under 1.51. So it's always a good idea to draw the picture so you've got an idea of what area you're looking for. And we then look at table A2. It's a positive z-score, 1.51. And as I said, you look on this side to get the first decimal, 1.5, and then 1. And then those two meet right here at 93.45. And since this matches this, that's going to be the answer. We don't have to do anything else. 9345. Next, what's the probability that it's over 2.10? So that would be to the right, shading to the right. Notice that that is a very small area, so the answer should be very small. So again, look up the z-score. So that's going to be 2.10. 0 is going to be the first column. So a 98.21. But 98.21 is for all of this area to the left. We actually want this area on the other side. Well, since the total is 100%, then this side is equal to 1 minus the shaded area. So 1 minus the 98.21 leaves 0.018, a very small answer. Like I said, this is a small area, so this small answer seems good. Next type of example, the z is between two numbers. So here we have z equals a -2 to a +2. Find the area in between. So when you look up a 2.0, that's going to be 2.0 is a 9772. Well, keep in mind that 9772 goes from here all the way to the left forever, which means that it's too much because it's also including this little left, we call it a left tail. It's including this left tail. So we're going to have to look up how much is that left tail and subtract it off, because that left tail is not supposed to be shaded. So that's coming from z equals a -2. So we need the other part of table A2, which is the negative z-scores. Notice that that gives you the left tail. And then look up a -2.0. So that's going to be a probability of 0.0228. And like I said, we then need to subtract that off. So when they say 0.0228, they're saying that's what this part is. So if you subtract the two answers, you'll then have the area in between. One last thing to note is when we did the empirical rule quite a while ago, it said that between two standard deviations, which is what this is at least 95% of the data. Well, now we have a more accurate way because it's actually 95.4%. How about when the z is between negative 2.78 and 0? So like I say, it's a good idea to draw the picture, indicate the shaded area, and we need to look up the negative z-score. So negative 2.78. Negative 2.7 is here. The 8 is here. And so those two meet right here. Now, on this picture, that's telling you what the left tail is. But we actually want from the middle over to here. Well, if it's the middle, then that would be 50%. So this, if you look at it, is about 50%, but take off this little tail. So 50%, subtract the 0.0027, a little bit less than 50%, 49.7%. Okay, the other thing that we do with this table is we work backwards. So with the previous problems, you're given a z, you find a percent. Given another z, find a percent. Perhaps you have to subtract from 1, perhaps you have to subtract the two answers, perhaps you have to subtract from 0.5, but you end up with a percent. What if you were given the percent? Then can you work backwards and find the z-score? So for example, what's the z-score needed to get into the top 10%? So here's a picture. The top 10% would be on the right. And if this is 10%, the other side of the line would be 90%. Then take a look at this table. So with the positive z-score, this is the 90%. And that's what these numbers in here are. So what you do is just search through this table until you find the one that's closest to 90%. It doesn't have to be over, it doesn't have to be under, just whatever's closest. And it's this one that's closest. And then usually what I do is I cross this out and I say I used 997. And then you use the table backwards. So you go this direction and you find out, oh, that means the z equals 1.2. You go this direction and the last decimal place is an 8. So the z that belongs right here is 1.28. Let's try one more. How about the z-score for P32? Do you remember the percentiles? Well, this means that the score is 32% of the way through the data. So you would start at the minimum, so down here, and then go 32% of the way through the data. There's the 32%. So where's this cutoff line for z? Well, because this is below 50%, then I know this is on the left side of the graph, and if it's on the left side, that's negative, because we have 0 in the middle, negatives on the left, positives on the right. So then just search and find what's closest to 0.32. There's 33. So let's see. Seems to be this one. This is the closest to 32. So 31.92. And then the z-score would be, go this direction, it's going to be a negative 0.4. Go this direction, and it ends with a 7. So that's the z-score, negative 0.47.